Okay, so you brought us a real head scratcher recently. Your Azure hosted web app and API, they've been hitting a performance snag.
Yeah, and you send over a bunch of material articles, your own notes, research,
Exactly. And our mission basically is to sift through all that and pull out the key insights. We want to figure out, not just why it happened, but what can actually be done about it.
and crucially, how to do it in a way that's cost-effective but also scales up if needed.
Right. Because your notes pointed to this big flood of requests coming from all over the place, lots of different IPs, and some acting pretty suspiciously, right? Repetitive hits.
Yeah, repetitive hitting specific pages and API endpoints again and again.
Hmm.
It wasn't just random noise. It felt, well, targeted. Maybe like someone was trying to overwhelm specific parts or, find a weak spot.
And the result was high memory use on the app service, slowdowns.
Pretty much. High memory load, things grinding to a halt, affecting the website, the APIs. A bad experience for legitimate users.
Okay, so it points to a denial of service attempt, maybe, or someone exploiting a vulnerability, or even just, I don't know, misconfigured bots running wild.
Could be any of those, honestly.
Mm.
The key takeaway is the impact. Serious performance degradation, real business disruption potential. It really highlighted a vulnerability, didn't it? The current setup couldn't really handle that kind of unexpected spike.
And the existing security, like Microsoft Defender for app service and just looking at logs manually, that wasn't cutting it this time.
Apparently not. Defender's great for known threats, but it doesn't offer that super granular control over individual request rates or sources that seems needed here. And manual IP blocking.
Yeah.
Well, that's just not practical when you're dealing with potentially thousands of shifting IPs.
You mentioned looking at Azure Front Door too, but the cost was a sticking point.
Exactly. Front door is powerful, absolutely, but it comes with a price tag. So the challenge became finding that sweet spot, good protection, scalability, but without, breaking the bank.
Right. So let's dive into the Azure native options first. What tools within Azure can give us that more fine-grained control over requests? Maybe starting with rate limiting and throttling.
Okay, so first thing to know is that Azure App Service itself, the core platform, it doesn't really have built-in configurable rate limiting features for your application specifically.
Ah, okay. So you can't just flip a switch on the app service plan.
Not really, no. Azure protects its own infrastructure, sure, but for your app's logic, you need something more specific. And that's where Azure API Management, or APM, really comes into its own.
Even though it's called API management, it can protect the web app too?
It can act as a gateway in front of both, yeah. It's designed for securing and managing APIs, but its policies are super flexible. It gives you that granular control. For instance, it has a basic rate limit policy.
Okay, how does that work?
It lets you set a cap, say 1,000 calls per hour, for a given API subscription key. But the renewal period is max 300 seconds, so it's more for shorter bursts.
Hmm. But the issue here was lots of different IPs, many maybe anonymous, not using subscription keys, right?
Exactly. That's why the rate limit by key policy is probably the better fit here. The key can be dynamic.
Dynamic how?
You can configure it to use, for example, the client's IP address as the key. So each individual IP gets its own rate limit counter.
Ah, that sounds useful. So you could say IP address X gets 50 requests per minute max.
Precisely. Or you could key it off a user ID from a JWT token if you have authenticated users. It's flexible. You set the number of calls, the renewal period, and the counter key, which is just the expression to generate that key, like context.request.ip address.
Can you let the clients know about the limits, like in the response?
Yep, you can configure to add headers like X rate limit remaining or X rate limit, so well-behaved clients can see how close they are to the limit.
Okay. Are there other related policies in ATM?
Yeah, there are also quota and quota by key policies. Those are more for longer-term limits like total calls per week or month, maybe for different usage tiers.
And what about stopping the back end, the app service, from getting totally swamped by too many requests at the same time?
Good point. That's the limit concurrency policy. It caps the number of concurrent requests being processed. Any more than that, just get rejected straight away with a 429 error. It's a crucial safety valve.
So APM seems pretty powerful for controlling the flow. Does it handle direct IP blocking too?
It does, yeah. It has an IP filter policy specifically for allowing or denying requests based on IP addresses or ranges. We can dig into that more.
Okay. But before we do, you mentioned something about APM's throttling maybe not being perfectly accurate because it's distributed.
Right. Because APM often runs on multiple instances for scale and resilience, the counters used for rate limiting might not be instantly synchronized across all of them. So you might see slight variations, maybe a few extra requests get through, or it blocks slightly early under very heavy load.
Hmm.
For most cases, it's fine, but it's, something to be aware of.
Got it. Good to know. Okay, let's talk about that direct IP blocking and also geo-restriction. What are the options there, starting with app service itself?
So Azure App Service has access restrictions. It's essentially an allowed deny list based on IP addresses, IPv4, IPv6, or even specific Azure Virtual Network subnets.
So you can say only allow traffic from our office network.
Exactly. Or block specific IPs you know are bad.
Right.
You order the rules, and there's an implicit deny all at the end if you add any allow rules, which is good practice.
Could you use that to block the attack IPs you found?
You could, yes. But the problem is, if the list of malicious IPs is large or changes constantly, managing that list manually in app service access restrictions becomes, well, a real chore.
Right. And you said it's all or nothing for the app.
Yeah, it applies to the entire web app. You can't say block this IP only for the login page. And it doesn't have any built-in way to block based on country or region, no geo-restriction.
Okay, so limited flexibility there. How does API Management's IP filter compare?
Much more granular. The IP filter policy lets you specify allow or forbid actions for specific IPs or ranges. And crucially, you can apply it at different scopes globally, just for one specific API, or even down to a single API operation.
Ah, so if only the API process endpoint was being hammered, you could apply an IP filter just to that.
Exactly. Very targeted. You can block the problematic IPs for that single operation without affecting anything else. What about geo-blocking with that policy?
Well, technically, you could try to maintain lists of IP ranges for countries you want to block and put them in the IP filter policy. But honestly, that's incredibly complex to maintain accurately. IP ranges change hands, new blocks get allocated. It's not really practical for reliable geo-restriction using just the IP filter policy.
Yeah, sounds like a maintenance nightmare. Okay,
Yeah.
shifting slightly, your notes mentioned concerns about protecting the Swagger UI. Why is
Right, so how do you protect it?
best practices? First, use IP restrictions, either app service access restrictions or, even better, the APM IP filter policy to limit access to only internal networks or specific dev test team IPs.
Makes sense. What else?
Require authentication.
Mm.
Azure AD, basic auth, something. Add another layer. Even if someone spoofs an IP, they still need credentials.
Good point.
Network segmentation can also help if you can isolate it. And definitely, regularly audit the access logs for that endpoint. See who's trying to access it.
Okay, so APM offers a lot more precision than app service alone, but you were looking for cost-effective alternatives too, especially if Front Door was too pricey. Let's talk web application firewalls, WFs.
Absolutely. Azure WAF is sort of the standard recommendation for protecting against common web attacks, SQL injection, cross-site scripting, things like that. You can deploy it with Azure Application Gateway or Azure Front Door.
And given the cost focus, you lean towards Application Gateway.
Probably, yeah. Specifically, WAF on Application Gateway v2. The v2 SKU is important. It offers really robust rate limiting through custom rules.
Custom rules, how does that work?
You define rules where you can set a threshold, say 100 requests a duration, maybe 1 minute, and how to group the traffic. You can group by client IP, by geolocation, or just have an overall limit. It uses a sliding window algorithm, which is pretty good at catching bursts.
So you could limit traffic from a specific country or limit requests to the login page from any single IP?
Exactly. It's quite flexible. You can also do standard IP allowed deny lists using custom roles too. And the pricing, while it has components, is often more manageable for regional deployments than Front Door's global setup. It's usually a fixed per gateway hour cost, plus a variable cost for capacity units processing the traffic.
Okay, and Application Gateway itself, what's its role beyond hosting the WA?
App Gateway is fundamentally a Layer 7 load balancer. It handles SSL offloading, routes traffic based on URLs or host names to your backend app services, provides session affinity, that kind of thing.
But the older V1 didn't have rate limiting.
Correct. The V1 S key lacked native WAF or rate limiting. You really need the V2 S key for the integrated WAF capabilities we're talking about. Think of App Gateway V2 as the entry point and traffic manager, and the WAF policy attached to it as the security guard checking everyone coming through.
Gotcha. What about Azure Traffic Manager? Does that fit in here?
Traffic Manager is different. It works at the DNS level. It directs users to different endpoints, maybe app gateways or app services in different regions based on things like performance latency, geographic location, or failover priorities.
So it doesn't actually see or filter the traffic itself.
Exactly. It just points the user's browser or client to the right place before the connection is made. It doesn't do any rate limiting or IP filtering. You still need wafer APN policies at the actual endpoint traffic manager directs users to.
Okay, so DWA on App Gateway v2 seems like a strong contender for that cost-effective enhanced protection layer. Now, assuming we have these controls, visibility is still key, right? Monitoring and alerting.
Absolutely critical. You need to see what's happening. Azure Application Insights is your main application performance management, or APM, tool here.
What kind of insights does it give?
Request rates, response times, server resource usage like memory and CPU, exception tracking, dependency calls,
Hmm.
a whole lot. You can see how your app is performing and how users are interacting with it.
And crucially, you can set up alerts.
Yes. You can create alerts based on metrics. For instance, alert if the average response time exceeds X seconds, or if the server error rate spikes, or importantly for this case, if requests from a single client IP address exceed a certain threshold in a short period. Real-time detection is the goal.
And for deeper dives into the raw logs.
That's Azure Log Analytics. It's a workspace where you can collect logs from pretty much any Azure Resource App Service, App Gateway WAF logs, API Management logs.
And you query these logs.
Exactly. Using the Kusto query language, KQL, you can write queries to hunt for specific patterns, like show me all requests to AP-sensitive data that resulted in a 403 forbidden error, or count requests per IP address hitting the login page in the last hour. And again, you can create alerts based on these log queries.
What if you want something more comprehensive, like a central security hub?
Then you're looking at Azure Sentinel. It's Microsoft's cloud-native SIEM security information and event management and SOA security orchestration, automation, and response platform.
Emin and SAR. Okay, what does that mean practically?
It means Sentinel can pull in data from all your sources, App Insights, Log Analytics, Azure AD, Defender, WAF logs, even non-Azure sources. It then uses clever analytics, including machine learning, to detect threats, correlate alerts from different systems into single incidents, and help you investigate.
And the SOAR part, automation.
Right. It can automate responses. So if Sentinel detects a confirmed malicious IP based on its analytics or threat intelligence feeds, it could automatically run a playbook, maybe an Azure Logic app, to block that IP in your way for API management policy.
Wow, okay, that sounds powerful.
It is. It provides that higher level intelligent security overview and response capability.
Let's switch back down to the application itself. What about security measures within the code?
Definitely another important layer, defense in depth.
Right.
You can implement custom middleware in your application pipeline.
Middleware, like code that runs on every request.
Exactly. It sits early in the request processing pipeline. You can use it to inspect requests, maybe do some filtering, or even implement rate limiting directly in your code.
Can you do rate limiting easily in code?
If you're using ASP.NET Core 7 or later, absolutely. There's built-in middleware now, Microsoft.ASP.NET Core rate limiting. It supports different algorithms, fixed window, sliding window, token bucket, concurrency limiting.
So similar concepts to APM and WF, but right in the application.
Yep. You can configure limits, time windows, and partition the limits based on things like, again, the client IP address, or maybe an authenticated user ID, or a specific HTTP header.
Is that cost effective?
Well, it uses your existing app service compute resources, so there's no extra service cost, just the compute cost of running the code. It gives you very fine-grained control tailored exactly to your application's logic.
But there was that point about reverse proxies, like application gateway.
Ah, yes, critical point. If you put something like App Gateway or APM or Cloudflare in front of your app service, your application code won't see the original client IP address by default. It'll see the IP of the proxy.
So any IP-based rate limiting or filtering in the code wouldn't work correctly.
Exactly. You must ensure the proxy is configured to forward the original client IP, usually in the X forwarded for header, and your application code needs to be written to correctly read and trust that header value. Very important detail.
Got it. What about other code level filtering, not just rate limiting?
You can implement request filters or validation logic. Check headers for weird values, check request body sizes or formats, validate query parameters. Reject suspicious-looking requests early before they hit your main business logic or database. Block known bad user agents, for instance. It reduces load and risk.
Okay, we've covered a lot of Azure ground. What about third-party options? Cloudflare came up in your notes.
Yeah, Cloudflare is a major player. They offer a global CDN, very robust WAF features, DDoS protection, bot management, and rate limiting. often considered a strong competitor to Azure Front Door, sometimes at a more attractive price point depending on your needs.
How does it integrate?
Usually you just update your DNS records to point your domain to Cloudflare's name servers, then all your traffic routes through their edge network first, where their security policies get applied before it ever reaches your Azure origin service.
And they handle things like rate limiting by IP, geo-blocking, etc.
Oh yes. They have very sophisticated rules engines for WAF and rate limiting, often with pre-built rule sets for common attacks, plus lots of customization options.
Are there other similar services? You mentioned one, OpenAppSec.
Right, that was in the source notes. There are definitely other third-party WAF and CDN providers out there. The key is to compare them carefully.
Yeah.
Features, performance impact, ease of integration, support, and of course cost. Cloudflare is just one well-known example.
Okay, so lots of tools. But the manual aspect of reacting is still a pain point. How do we get to automated detection and blocking?
That's really the goal for sustainable protection. We touched on it with Sentinel, but you can build simpler automation too. Start with Azure Monitor alerts. Set thresholds like more than 100 requests per minute from IPX.
And when the alert fires?
Trigger an Azure Logic app or an Azure function. That app or function can then run code to automatically add the offending IP address to, say, the deny list in your app service access restrictions, or the IP filter policy in API management, or a block rule in your way.
So near real-time blocking based on thresholds.
Exactly. It drastically reduces the time attackers have to impact your system.
What about more proactive blocking?
That's where threat intelligence feeds come in. If you integrate Sentinel or some WAFs with these feeds, they get constantly updated lists of known malicious IPs, domains, etc. They can block traffic from those sources before they even try to attack you.
And the machine learning stuff for finding weird patterns.
Right, anomaly detection in application insights or Sentinel. These can spot deviations from normal traffic patterns, even if they don't cross a hard threshold you've set. Maybe a sudden burst of traffic from an unusual country, or requests hitting endpoints in a strange sequence.
And automate responses to those anomalies too.
You can. Trigger an alert for investigation, or if confidence is high, potentially trigger an automated blocking action. It helps catch more sophisticated or subtle attacks.
But isn't there a risk of blocking legitimate users with all this automation? False positive?
Absolutely. That is the key challenge. You must continuously monitor the results of your automation. Review the blocks, check your logs, look at user feedback. You need to tune the rules, adjust the thresholds, refine the anomaly detection models over time. It's not fire and forget.
Requires ongoing care and feeding.
Definitely. Otherwise, you risk blocking good traffic, which can be just as bad as letting bad traffic through. Regular view and tuning are essential.
Okay, this has been incredibly thorough. Let's try and pull it together. Based on everything we've discussed and keeping that cost effectiveness goal in mind, what are some initial recommendations? Recognizing, of course, that a detailed cost analysis is needed.
Sure. Based on the scenario, implementing Azure API Management seems like a really good move, especially for the API. Using rate limit by key based on IP address and the filter policy gives you that targeted control. The consumption tier might be a good starting point cost-wise.
Okay, APM for the API. What about overall protection?
For both a web app and API, deploying Azure WAF on Application Gateway v2 looks like a strong candidate. It balances solid security features WAF rules, custom rate limiting by IP or geo, IP blocking, with a potentially more predictable cost than Front Door for regional needs.
And the monitoring piece.
Absolutely essential. You need Azure Application Insights and Azure Log Analytics for visibility. Set up those alerts. Yes, they have costs based on data volume, but the insight you get is invaluable for detecting issues and tuning your defenses.
Any alternatives if Front Door's cost is really prohibitive?
Definitely evaluate Cloudflare. Compare its features and pricing against WAF on App Gateway v2 and even APM. It might offer a compelling package, especially with its global CDN benefits.
And you had a hypothetical cost table in the notes, right? Just ballparks.
Yeah, just example estimates to give a rough idea. Costs depend heavily on traffic, data volume, specific configurations, regions. You really need to model it for your specific situation using the Azure pricing calculator or talking to Azure Cloudflare sales.
Understood. So if someone were starting this journey, what would a phased implementation look like?
Good question. I'd suggest phases. Phase 1, immediate stuff. Manual blocking of known bad IPs and app service, maybe some quick basic code level rate limiting if possible. Stop the immediate bleeding.
Okay, triage first.
Phase 2, build the robust foundation. Deploy API management for the API. Rate limiting, IP filter. Deploy WAF on Application Gateway v2, or implement Cloudflare after evaluation for overall protection. Get those core network-level controls in place.
Makes sense. Phase 3.
Phase 3, visibility. Configure application insights and log analytics properly. Set up meaningful alerts for high request rates, errors, suspicious IPs, resource exhaustion. Understand what normal looks like so you can spot abnormal.
And finally,
Phase 4, automation and refinement. Explore Azure Sentinel if the complexity warrants it. Set up automated blocking responses using logic apps or functions triggered by your alerts. Start leveraging threat intelligence and anomaly detection. Continuously tune.
that sounds like a solid plan. Any key best practices to keep front of mind during all this?
Yeah, a few. Start restrictive with your rules, rate limits, IP filters, and loosen carefully based on monitoring. Test everything in staging first. Don't experiment in production.
Good one.
Regularly review and update your rules threats change. Monitor performance after changes. Make sure you haven't slowed things down. Apply rate limiting. Strategically focus on critical endpoints first.
And be nice to the clients who hit the limits.
Exactly. Use the standard HTTP 429 too many requests response. And if possible, include a retry after header, telling them when they can try again. It helps legitimate clients recover gracefully.
This has been incredibly helpful. It really paints a picture of needing a multi-layered approach, doesn't it? Combining something like API management with WAF on App Gateway, maybe Cloudflare, and crucially, that continuous monitoring and alerting layer.
That's the key takeaway, I think. There's no single magic bullet. It's about building layers of defense, having visibility, and automating where possible, all while keeping an eye on the cost implications. And remembering it's an ongoing process.
Right, not a one-and-done project. The threat landscape keeps shifting, so your defenses need to adapt too. Continuous monitoring, regular reviews, it's essential.
Absolutely.
So maybe a final thought for you, our listener, to ponder. Given this constantly evolving nature of online threats, what proactive steps, perhaps even beyond these technical tools we've discussed, might be most critical for the long-term resilience of your application? Something to think about.
A good question to end on.
Thank you so much for sharing all your source materials and allowing us to really dig into this situation.
That's all.
Hopefully this deep dive provides a clear path forward